Okay, so now we're going to look at a problem that, to show that this validly follows from these premises, you'll need to do more than one step. So you'll need to use one or more of these rules. Maybe one, but you'll have to use it twice. You need to make at least 2 steps. So first look at what you need to show validly follows. Can you find t anywhere in here? Where do you see t? What line? And it's in a horseshoe. And it's on the what side of the horseshoe? Left. As soon as you see what you want to prove on the left-hand side of a horseshoe, MT should light up in your mind, because MT is the only way you're going to get the left-hand side of a horseshoe by an inference step. But what 2 things do you need to do MT? You need a horseshoe, and you need the opposite of the right-hand side. So I've got the horseshoe, but I do not have the opposite of the right-hand side. I don't have squiggle R anywhere. So I have to make a step to get squiggle R before I make the step to get squiggle T. So I now have a new problem. Find squiggle R. That is not squiggle R, and it will never become squiggle R because it's on the right-hand side of a horseshoe. Do you see R on the left-hand side of a horseshoe anywhere?
Yes.
What line? R is in a horseshoe on the left. MT, MT. MT is the rule. It says I need a horseshoe and the opposite of the right. I've got the horseshoe. Do I also have the opposite of the right-hand side? What line is it?
3.
So, I can now take the step to get squiggle R. Because I have the horseshoe and the opposite of the right-hand side. MT, and I have the horseshoe, and I have the opposite of the right-hand side. Now I can get squiggle T, because I have the horseshoe, and I have the opposite of the right-hand side. So I can get squiggle T by MT using that horseshoe and the opposite of the right-hand side. And I'm done.